Hey everyone, welcome to homework 3.6. So today we looked at more exponential functions and analyzing some of those graphs. So let's take a look. These two graphs show models characterized by exponential decay representing the area covered by two different algae blooms. More algae, okay? W weeks after different chemicals were applied. Which bloom covered a larger area when the chemicals were applied? Explain how you know. So that would be this red one on your paper, the triangle one. Okay, so the triangle bloom because the vertical intercept or the y-intercept is 500 and the other one is 200. Which algae population is decreasing more rapidly? Explain how you know. All right, so to figure that out, we're going to need to look at what the factor is, right? So just by looking at the graph, it appears that the triangle one is decreasing more rapidly, but let's take a look at the factor here. So at the first week, it's about, let's estimate 340. And the initial amount was 500. All right, and so if we calculate this, it'll give us a factor, and that'll tell us what it is decreasing to, right, what the new amount is. And so in this case, it is 0.68% of what is initially there, which means that we are decreasing by 32%. So the factor is 0.68, but the decrease is 32% for the red one. Now for the blue one, let's take a look at that one. We're going from about, let's say this is 150 here, so maybe we'll say 150, 160. So 160 divided by 200. And so if you do that, you will get 0.8, which means that that is how much remains each time. So 80% remains, which means the decrease is 20%. So this means that the triangle is decreasing faster because it's decreasing by 32% each time, whereas the circle one is decreasing by 20%. So we'll say triangle is decreasing faster. Notice that the amount left is less than this one, which also shows us that it is decreasing faster because less is remaining each time. All right, a medicine is applied to a burn on a patient's arm. The area of the burn in square centimeters decreases exponentially as shown in the graph. So the area of the burn starts at 8 square centimeters. What fraction of the burn remains each week? So we have, looking at week 1, 6 over 8, which is 3/4 or 75%. So 3/4 remains each week. That's our factor. It says write an equation representing the area of the burn. So A equals, our starting amount is 8 times 3/4, or you could write that as 0.75 to the power of t. So after 7 weeks, we would have A equals 8 times 0.75 or 3/4 to the 7th power. And you can use your calculator to calculate. That's what I'm going to do as well. 0.75 to the 7th power. Remember, the exponent part has to be done first. Times 8 is going to give us 1.0678. So 0.68, because we're going to round to 3 decimal places. And that would be centimeters squared or square centimeters. All right, the area of a sheet of paper is 100 square inches. Write an equation that gives the area A of the sheet of paper, and square inches have to be folding in half. So the folding in half is losing half of its area, right? So A equals 100, that's the original amount, times 0.5 or 1/2 to the number of folds that we do. The area of another sheet of paper is 200 square inches. Write the equation B of this and being folded into thirds n times. So here we have this going to be 100 times our factor to the nth power. Now in this case, if it's being folded into thirds, then the area is going to be a third of what it was before. And so you don't need to subtract from 1 here because 2/3 isn't what will be left. Because I'm folding it into thirds, that paper, right, however I'm folding it, 1, 2, 3, right, will be split into 3 parts now. And so the area will be a third of what it once was. It says, are the areas of the 2 sheets of paper ever the same after being folded n times? Explain how you know. So when 100 times 1/3 to the power of n equals 100. Oh, you know what, you all? I didn't catch that. This should be 200. Sorry, 200 is our starting amount. So 200 times 100 to 1/2 to the nth power. All right, so if we were to try and calculate this, we would need to find a number n that would make these equal to each other. And that is quite unlikely to try and find a number that will be true in this situation. Let's take a look at the next one. So if we look at these graphs, this is medicines in 2 patients. So we have a circle medication and a triangle medication. So patient A is the circle, patient B is the triangle. One equation that gives the amount of medicine in milligrams in patient A is this equation here. So patient A is the circles. So this is patient A. That means they're starting at 300 here. What could be an equation for the amount of medicine in patient B? So assuming this is 300, then this would be 200, this would be 100. We're going up by hundreds. So that means the starting amount for patient B is 200 times. And now notice here, let's assume that this is 200, then this piece right here, that dot right there, is maybe 140, we'll say. 140 over 200 is going to be 7/10 or 70%. So 0.7 to the power of h. And notice that in this case, that makes sense. This one's decreasing by half each time. This one is decreasing by 30%. So a smaller, we see that that decrease is looking a little bit less, and that's why the circles end up below the triangles, even though they're starting at a higher value. All right, now, and actually, I'm sorry, there was a multiple choice option. So here, that is probably the best answer there. If you chose 3/10, that would represent what is left, that 3/10. This is what we're taking away. So we're taking away 30% each time. We're left with 70%. All right, your last one says select all expressions that are equivalent to 3 to the 8th power. So remember that when we multiply like bases, we add the exponents. So B would be true. This would be 3 to the 6th power, so that is not true. Likewise, we subtract when we divide. So this would be 3 to the 14th power, so that is not true. This one here would be 3 to the 8th power, because 12, this would be 3 to the 12th minus 4. And then here, when we have an exponent raised to another exponent, we multiply. So that is true. This would be 3 to the 7th power, so this is not true. All right. Now, let me go back to the classwork. Let me go back to the classwork really quickly to these park practice problems if you need help with those. Before I do that, your code word for today is fruit snacks. Fruit snacks, put that at the top of your paper in the code word section. And then if you need help with these park practice problems, you can follow along with me now. So at the end of year 0, City M has a population of 23,500 that is growing at a rate of 5% per year. So this is population City P. So we have another city, City M, and its 0th year is 23,500. So when in doubt, remember I said make a table. I would strongly suggest that you do that for this scenario because we have one that's already in a table. Let's make the other one. It's growing at a rate of 5% per year. This means that my factor is 1.05 because it's growing, so I'm adding 1. I'm going to add that 5% each year. Then we have the population of the city P at this year is 23,000, and this is shown over a 4-year period. So now we want to see if the growth rate for each city does not change, which statement about the populations of city M and P is true. All right, so in order for us to figure that out, we need to make some comparisons here. Here we know that the growth rate is 5%, and so the factor is 1.05%, or 1.05. It's growing 5% each time. Here, let's find the factor. So 24,380 divided by 23,000 gives us a growth rate of 1.06. Let's confirm that, not a growth rate, a growth factor. Let's confirm that 25,843 divided by 24,380 is 1.06000. So that's also close to that. All right. So the growth factor for here is 1.06, which means the growth rate is 6% versus this one has a growth rate of 5%. So it says which one has the greater growth rate. So it says city M has a greater growth rate. We already know this part is not true. So this cannot be true because city P has a greater growth rate. City M has a greater, nope, also not true. City P has the greater growth rate and the larger population at the end of year 2. Well, let's calculate what the population would be for year 2 here. Here we're multiplying by 1.05. So 23,500 times 1.05 gives us 24,675. All right, so in this case, city M has a larger population at the end of year 1. Let's try year 2. So that amount times 1.05 gives us 25,908. That's for year 2 here. This is for year 2 here. So city P does have a greater growth rate, but not a larger population, right? City P has a greater growth rate of 6%, but this population is less than this in year 2. So this is not true, which means city P has a greater growth rate and a smaller population, right? 25,843 is less than, nope, I did that backwards, greater than this. This population is less than this population. So this population is greater than this population. And so your correct answer is D. Let's take a look at practice number 2. A t-shirt company bought a new packaging and tracking system for $100,000. Starting amount. This is the formula and it shows the value of the system in dollars after depreciating, going down for Y years. So we know this is a decay model. In this formula, what is the meaning of 1 minus 0.125? So the 0.125 is the rate, right? And the rate is how much it's decreasing by each year, okay? So we should look for something that tells us how much it's decreasing by. So the value of the system will be 0 in 12.5 years. No, that doesn't have anything to do with that. The value of the system will decrease by 1250. So this amount doesn't represent a dollar amount. Remember, that represents a decimal percent, so that is not true. The value of the system will decrease by 12.5%. Well, if we have 0.125 and we multiply that by 100, we would get 12.5. So this seems like a likely option. Let's check out D though. It's important to read all of the answer options. The value of the system will continue to decrease for 125 years. No, that makes absolutely no sense. Okay, so you know that the answer is C. And we say because we subtract 0.125 from 1, this is the decay rate. Sorry if you can hear my dog in the background. This is the decay rate, and 0.125 times 100, so in percent, it is 12.5%. Okay, so you should have an explanation similar to that here for that one. All right, that is that. If you have any questions, please feel free to reach out. Hope you have a wonderful weekend and happy homeworking.